Good morning, everyone. Welcome to our webinar. This one is titled DBT Essentials. It's part of a Modern Data Mastery series of webinars that we run. Vicky's in Perth. My goodness. Yeah, you absolutely want to get a coffee machine right on the boil next to you, Vicky. I hope wherever you are, you're having a terrific morning and are ready to spend the next hour with us. Just before we get started, I'll cover through a little bit of housekeeping. So first and foremost, this is a recorded session. What we do is we share these on both our YouTube and LinkedIn channels afterward, so that if you want to share that with some of the rest of your team, there'll be links provided after the fact. The session goes for about an hour, and we will leave a little bit of time for questions in the end. We can also run over by 10-15 minutes if needed. But in terms of questions, feel free just to type them into the chat as we go along. Some of them might be aggregated as well. Now, there's going to be also a couple of polls on the way through. So we'll let these shape some of the discussion for today. Lastly, at the end, if you've got any specific questions on DBT and would like a follow-up session tailored to the context of your business, we'll absolutely be happy to do that with you. So with housekeeping out the way, let's jump in. I'm Artem. I head up sales for Revenite. And with me is Sam Fischer, who is one of our lead consultants. For those that don't know Revenite, we're a specialist data and analytics consulting business. We're based out of Melbourne and primarily work on the East Coast, operating across the enterprise and mid-market customers. A majority of our work tends to be focused on Databricks and Microsoft, really from ranging from services like design and deployment of data platforms through to data migrations, data engineering, and all the way to delivery of data assets like models and reports for our customers. Our customers continually look to us for tools and patterns and processes to help them standardize and accelerate delivery across that service stack. And examples of this include things like our metadata-driven ingestion framework with certain industry connectors, specific data ops processes. Today, however, we're talking about leveraging DBT really as part of your data development practice. So before I hand over to Sam, I'm going to kick off just the first of our polls. It'd be really useful to understand where each of you is in your DBT journey to date, just to gauge where that level of experience is. So you should see that come through momentarily. But for now, I'll hand over to Sam.
Perfect. All right. Thanks, Artie. So again, my name's Sam Fischer. I'm a lead consultant here at Revenite, and this morning we're here to talk about some DBT essentials. So to go through our agenda for this morning, we'll start off by understanding what is DBT as a tool, and then we'll go through what kind of problems it can solve for you within your data platform. And from there, we'll go through what are some of the steps along the way to achieving maturity with working with a tool like DBT. And then as part of that, we'll go through some of the different offerings of DBT that can help you really supercharge that maturity journey as well. And then finally, we'll go through a bit of a demo so we can understand how the tool works hands-on. Finally, at the end, we'll go through some Q&A. There may be some questions that naturally make sense to answer over the course of the next hour rather than waiting until the end. If that's the case, I'll defer to Artie to ask those questions for you on your behalf. All right, so first natural question, of course, is what is DBT? Because it's a tool that's been getting a lot more traction in the data community, especially over the last few years. So DBT, as an acronym, stands for Data Build Tool. And it's probably important to know because if you just Google DBT without any context, you're going to be directed to a certain form of therapy rather than an actual tool for data engineering. So Data Build Tool, in this context, it's a command line tool that enables data engineers and analysts to transform data more effectively within, say, a cloud data warehouse. So it's a tool that was created by a company that's now known as DBT Labs, but they originally started as a consultancy working with cloud data warehouses. They found that working with them in the early days, they tended to be quite error-prone, and led to a lot of inconsistencies as to how they were used kind of day to day by data engineers. So they developed this tool to leverage a lot of software engineering principles to allow for more effective delivery of that. So what does it do? So it actually does the T in your ELT process. So it helps to look at a bit of a reference architecture, understand how it fits in. So in a typical data platform, you'll have sources providing data coming in. The data platform will be there to provide insights for downstream use cases like BI and data science. But within your platform, whether it's Snowflake or Databricks or Microsoft Fabric, you've typically got layers of data. These days, you might structure that as a medallion architecture, where you'd have a bronze raw layer, a silver transformed layer where you're applying transformations before you ultimately serve it to your end users in a gold layer. So DBT is how you can actually move data between those different layers just by defining transformations all within your data tool there. So the real utility of DBT comes from the fact that you can define your tables and views not just in SQL but in other languages that provide different configs. So you can also implement some templating within there. What DBT as a command line tool will do is it will take that code that you defined, compile it into SQL that can be interpreted by your data platform, and then it will run that against the platform. And one of the other really powerful elements of it is that oftentimes when you're managing a data platform, it's not just defining the tables themselves that matters, but it's the lifecycle management of it. So it might be defining your create table statements, defining your stored procedures to run all of your tables in order to make sure that whenever you get new data coming in, that it's all consistent. So the power of DBT is that you only have to worry about defining your select statements for the actual transforms that you use to define each layer. So all those other bits of logic that you would typically need to manage a data platform, they're all handled for you and wrapped up behind the scenes. And that's where one of the real useful points of DBT is as your platform grows, you start to have more tables that you're supporting, and you're having more complex dependencies between different artifacts within the platform. It helps you to manage that complexity a lot more easily because if you are having to define all of your stored procedures along the way, that would grow naturally over time. But if you don't have to worry about that, then it allows you to keep things a lot more simple as you mature with the use of the tool. So as part of this tool, there's a number of different features that it offers, and they offer a number of enablement features for members of your data team. So as far as the features themselves, the key ones are that it provides this boilerplate deployment code. So behind the scenes, it does the work of what you would classically use for stored procedures, or maybe you've got notebooks, say in Databricks, that orchestrate a lot of the execution of tables. That's all handled for you in the background. And again, you just focus on the select statements. It also, as we mentioned, is able to compile SQL, not just from raw SQL itself, but also by using a templating language. That templating language in DBT is called Ginger. So when we go through the demo, whenever you see little curly braces there, that'll be some of that templating. And it means that you can keep the SQL a lot more interpretable rather than having, a 300 or 400 line SQL script. You can modularize things and make it a lot more readable for your developers. It also has native lineage and dependency management. So if you want to understand how different artifacts are related to one another, it's very easily handled out of the box. So you can understand whether or not you're going to make a breaking change if you've got to apply hot fixes or if you've got to cater to new requirements in your platform. And as part of the software engineering capabilities it has baked in, one of those key ones is continuous integration. So instead of having different data engineers bottlenecked by one another, waiting for each other to finish work on different projects, you can allow for development on different feature branches, integrated all together with the continuous integration features. And once you've been able to build all that out, you also want to make sure that you haven't broken anything along the way. So that's where that idea of doing automated tests at every step is particularly useful. So you can make sure that any other change that you've introduced, you haven't broken anything that's come before. And it also has a feature of data contracts. So you can hold to account your upstream data providers and know straight away if there's any deviation from the form of the data you expect to receive. Also, it comes with out-of-the-box documentation features. So as we'll see in the demo, you can define documentation along the way, and that will be realized not just in your code, but in a business-friendly way for your end users. And then finally, as well, because the usage of DBT has really taken off over the years, a number of different organizations and individuals have defined their own packages they've shared with the community. So instead of having to rebuild things from scratch, you can utilize on the collective knowledge of the community and really, again, supercharge your maturity with using the platform there. So those are a lot of the key features there, and it also helps to think about how these key features tie into the needs of different members of your data team. So typically when you're delivering a data product, you would have people like data engineers, data analysts providing those insights to business users, and then platform owners having overall oversight. So it helps to think about what are the things that they're concerned with. So if you imagine that you're a data engineer, some of the things you're thinking about are going to be, say, around source systems. So you want to make sure that your source systems provide the data that you need and they provide it on time in the format that you expect. So by defining data contracts within DBT, you can have a lot more visibility over if those expectations are being met along the way. You're also thinking about collaboration. How can I collaborate with my fellow data engineers? How can I collaborate with data analysts rather than being siloed away? So those continuous integration features and being able to see how the work that you're doing integrates with the work of your fellow data engineers, that really helps as well. And also you're going to be thinking about data impacts. So say I have a new requirement that's come in or I need to bring in a new data set. How can I make sure that I'm not going to cause any downstream issues by bringing that in? So that's where your native lineage and dependency management helps you trace that so you don't have to do any guesswork about it. So now say you're a data analyst. So as an analyst, you're going to be concerned about things like traceability. So the data that I've received, where has that actually come from? Maybe I want to know if it has come from the source system that I expect because things operate differently in terms of business rules between different sources. So I can trace that with my dependency management. I'm thinking about translation. So I'm trying to work out how I can take the backroom work of the data engineer and how I can translate that into something more palatable for our business users. So the documentation features allow for a lot more collaboration between different people involved in the project. So I can surface that to business users in a much easier way. And then I'm also thinking about reuse. Maybe I'm querying the same tables from my data platform and I'm querying those multiple times to build out different reports. So as soon as I start to deviate, that causes some redundancy and I want to be able to trace what I'm doing. So the ideal scenario would be that I push all that up into my data warehouse. And oftentimes you might go to your data engineering team and say that, but then you end up waiting in a queue for 6 months for that to actually happen. So because of the continuous integration and because also with DBT, I'm just focused on the transformations and DBT handles the rest. With my skill set as a data analyst, I'm much more equipped to be able to, instead of make that request to the data engineering team in the form of, say, a Jira ticket, I can make the updates in code and lodge that as a pull request. So that can really tighten up the feedback loops as well, so that I can be much more involved in the process. Next, we've got our business users. So as a business user, I'm thinking about what's the actual context of the data that I'm looking at. It's not just ones and zeros, it has a real world meaning. So by understanding that context that's come through from the very start in the documentation area, that becomes a lot clearer for me. And then I'm also concerned about, can I actually trust the data that I'm seeing to make informed business decisions? So with the automated tests that I can see taking place every time that data is refreshed, I can be sure that the insights are rock solid. I don't have to take anyone's word for it. And then finally, as a platform owner, I'm thinking about what's the overall health of the platform and even data quality across the platform as well. So for platform health, there's a number of packages that others in the community have defined that allow us to track things like best practices. So in order to ensure quick delivery, I want to make sure my engineers and analysts are all looking at the same structure of project. And I can audit that with some of those packages that allow me to see if those best practices are being met. And then I'm also thinking about data quality across the whole platform so that I can have trust my C-suite stakeholders so they can trust the platform overall. So again, I can compile and aggregate the data quality results across all my DBT projects and see that all in the one place as well. Okay, so within my data team, so let's say that we've played around with the tool a little bit and we're trying to understand how we can actually build up our maturity with a tool like DBT. And we tend to classify this into probably 4 different stages of maturity. So the first one of those is around you're just starting off with assessing DBT. So this is where you're learning about the tool. Maybe you haven't come across it in much depth before. Maybe you're attending a webinar on it, and you're assessing value and trying to determine what's the return on investment for using a tool like this. The next stage in that journey is actually hands-on exploring that. So you're kicking the tires, or you've already kicked the tires. You've built a few models within DBT, and you're looking to take those through to production. And the next stage is you're really establishing DBT. So you've maybe gotten a few projects through to production, and from that, you're looking to take more people on the journey and onboard more use cases into your data warehouse. And then finally, that real nirvana state is around your standardizing DBT. So as you've deployed a few projects out there, you've worked out the kinks of how the tool works, and you're working out what works best for your organization to allow you to really scale your usage of the tool over time. So with those being the 4 stages of maturity, we're just going to pop another poll in the chat where we're keen to understand what is your level of maturity at the moment, and more importantly, where do you see your company aiming to go as far as maturity with the tool over the next 12 months. So again, it might be that you're just starting out with the tool, you're going through that assessing phase. Maybe you've played with DBT a little bit, so you're exploring it, or you're really comfortable with the tool and you're starting to establish and really standardize things here. So I can already see we've got a few responses to come through the chat, which is good. So it looks like a lot of us are in that early stage of kind of assessing the tool and starting to explore it a little bit. So the good news is that going through the rest of this talk, we're going to cater to a lot of those kind of questions you might have implicitly there. But the other thing that I'll point to is that with using a tool like DBT, there are different offerings that can help you to differentiate how quickly you go through that maturity journey. And that's with the 2 offerings that DBT has that are known as DBT Core and DBT Cloud. So the difference between the 2 is that DBT Core acts as an open source offering where you're provided with a command line tool. You're provided with the same features that we've already gone through earlier on, but you've got to manage all the related infrastructure and tying into the data platform yourself. With DBT Cloud, this is a managed software as a service offering that's provided by DBT Labs. And this gives you a lot more features that can help you mature your usage of the tool faster, especially if you're just building out a platform and you haven't got other tools at your disposal just yet that you want to integrate with. So as far as the differences between these 2 offerings, so here's the list of all the different features that we already went through. And good news, both offerings cater to all these different features as well. But the distinction comes from your add-on features that you can get with DBT Cloud. So with DBT Cloud, you also have access to a browser-based IDE, so you don't have to worry about as many of the manual configurations, and you can also access that anywhere rather than just being tied to a particular machine. You've got native job orchestration. So with that boilerplate deployment code that DBT provides, you'll still need to orchestrate that, and you can use other orchestration tools, or you can just rely on DBT Cloud to manage that for you. It also provides even more advanced lineage and governance tools with one of their products within it, DBT Explorer. So this is a tool that gives you even more insights, allowing you to go down to even column level lineage of, say, how different tools are being formed. We've also got multi-project support. So as you start to go through those later stages of that maturity journey, you may have a lot of different projects that you're working with, and those projects may have interdependencies, so they depend on one another. So you can build out lineage views yourself, or you can use tools such as DBT Mesh, which gives you much clearer and easier multi-project support. And then finally, what's the direction that a lot of organizations are going in is relying on a centralized metrics repository or metrics layer. So you can, instead of defining your different business level measures across different tools, you can define them all in the one place. And dbt semantic layer is a tool that allows you to do that. That's also available with dbt cloud. Okay, so now that we've gone through the different features that are involved there, it helps us actually get hands-on and go through a bit of a demo to see how the tool works in practice. So the demo that we're about to go into helps to understand the journey that we're going to follow in this demo. So the first thing that we're going to do is within the data platform that we're going to use, we're going to be using Databricks, and we're going to start by connecting up dbt and seeing what that experience is like. The next thing that we're going to do is we're going to define our data sources and see what that looks like in our raw layer and how we can use those within dbt before we perform some light transformations to see how it works in the silver layer. And then finally, we're going to play around with the business ready data, and we're going to see how we can expose that to our end users in terms of serving the documentation alongside as well, and also proving that it has high data quality with tests. And then finally, before we dive in, I'll just take you through some key concepts that are relevant to both dbt and the demo. So for context, the data that we're going to be working with comes from an organization, a fictitious organization called Dappleshop, and their whole bread and butter is making toasted sandwiches for 365 days of the year. The tools we're going to be using, we've got Databricks as our data platform, and we're going to be connecting to Databricks with dbt using Visual Studio Code. Now, the languages that we're going to be using, of course, we're going to be playing with SQL, but there's a few other languages that may be a little new to some of you. So the first of those is Ginger. So again, Ginger is a templating language that we can use to modularize our SQL and make things a lot easier to understand. But there's also another language called YAML, which stands for yet another markup language. And that's the language that we use to define a lot of our configs. It's kind of like JSON, but even easier to read than that. So it should be pretty easy to pick up. And last but not least, there's a few different artifact types that we tend to deal with within dbt. So the four main ones that we're concerned about for the sake of this morning's demo is models, seeds, macros, and tests. So in the context of dbt, when we talk about a model, it's a little different to what you typically think about because working with data, when you think about a model, you're probably thinking about, say, a star schema or a relational model where you've got multiple tables connected via relationships. So in the context of dbt, when we talk about models, we're not talking about that construct, but we're really talking about those tables and views that comprise, say, your star schema. So that when you hear me talk about models from now on, that's what I'm going to be referring to. We've also got seeds. So a seed in dbt is typically used for defining reference data that we can pull into our project, but we're going to be using it a little more than that. Next, we've got macros, which is, again, something that we can define in Ginger as some reusable functions that we can use throughout our dbt project. And then finally, we've got tests. So our tests allow us to find our expectations of what the data should look like so that we can find out if those expectations are ever violated. All right, so with that, let's dive into our demo. So to start off with, let's actually have a look at our data platform to get started. So again, we're working in Databricks, and we're going to be using a schema called Dappleshop demo. We've already got a number of different tables loaded into Databricks here. So we've got tables for raw customers, raw items, raw orders. So we've got 5 tables here. And these data would have typically already been loaded in from another tool just to ingest, because remember, dbt handles the T in ELT. So that's our data platform. Let's look at our local development environment. So I'm just going to be using Visual Studio Code for this. So I'm going to start out by actually opening up my Git repository or my local instance of that. If I just track that one down. So I've already got my Git repo synced, and I'm just connecting to that here. So this is what a typical dbt project looks like, where I've got a number of subfolders, which would typically map onto those different artifacts. So you can see models, seeds, we've got data tests here and macros. But we're going to start out with connecting to our data platform. So in order to connect through VS Code, there's a few config files that we need in order to do that. So the first of those is our profiles.yaml. So this is an example of what YAML looks like as a config language, and it's, as we said, it's similarly structured to JSON, but it's a bit easier to read because instead of worrying about the curly braces like you would in JSON, we just got these indents to describe the nesting of the different layers here. So our profiles allow us to define how we can connect to that to our data platform. So here I've got a profile called Jaffle Shop, where I'm connecting to Databricks in the DBT demos catalog and then the Jaffle Shop schema. I've got other connection details here, including the token that I'm going to use for authentication. And that's just hidden away as an environment variable. So the other important config I have is my DBT project YAML. So this is where I can define things like what version of DBT that I'm using. I can define where DBT should find the definitions for my models, my seeds, my macros, and my tests. And I can also define for the different layers, my bronze, silver, gold layer, how should they be materialized? So here I've got my silver staging layer is all going to be materialized as a view, and my gold mask layer is going to be all as tables. So I can, if I wanted, I could go even more granular than that rather than just at the different layer level. So with these two configs, I've got what I need to connect up to Databricks. So what I can do is from the command line, the first thing I'm going to do is I'm going to run a little shortcut to activate my virtual environment here. And that's going to set up a Python environment that I can work from. Next, I can just run a simple command called dbt debug. And what that command is going to do is that's going to parse through my project, dbt project YAML. It's going to parse through my profiles YAML. It's going to confirm that the format of those is okay and valid. And then it's going to attempt to connect up to Databricks here and just verify that connection's working. And as you can see, that connection's worked. So we know that we can now develop against DBT here. So now that we've got that up and running, we've now got so we've got our 4 different artifact types that we mentioned before: our models, seeds, macros, and tests. So it helps us start thinking about seeds because that might be where you might start bring in, say, reference data. So if you've got reference data that's not changing very often, that's what you store as your seeds here. For this demo, or this project is fairly self-contained, so I've actually used my seeds to define my transactional data from my source systems. So you wouldn't typically do this. You would rely on another tool because you wouldn't want your data just stored in source control. It's not very efficient. But for the purpose of this, to showcase the capabilities, it's useful to see, say, this raw stores seed here. So you would have noted before we had 5 tables within our data platform, and we didn't actually have a raw stores table here. So this is the kind of reference data that if it's not moving very quickly, it's a bit more acceptable to maybe have this in source control, or if it's not expecting to change very often or at all. So here I've just got a CSV file that defines what are the IDs, names of my stores, what were the dates they opened at, and what's the tax rate that applies to them in this CSV format here. So one of the useful things, if I have this reference data, if I need to bring this into, say, Databricks otherwise, I might have to define a create table statement in SQL. I might have to do all my inserts here, but it's a lot easier with DBT because what I can do is I can just run a DBT seed command, and that's going to actually seed that data in my warehouse. Now, if I execute this command just as it is, it would populate all these CSVs in here. And as you can imagine, we've got a lot of customers for this store, so that might take a little while. So instead, I'm just going to select a single model, a single seed. So I'm going to select my raw stores, and I'll just let that run in the background. But while that's running, what that's actually doing for me is that's taking this CSV value, this CSV file, it's parsing through it to understand what's the schema that it should infer to send through to Databricks if I happen to find that otherwise. And then it's going to be constructing the SQL required to actually push that up to Databricks here. So you can see that it's been running for about 10 seconds here. Give it a little moment. There we go. So it's now constructed all the SQL. It's now inserted that into the warehouse. And we can actually see that if we look here and I just refresh our schema. So we can see we've got our raw stores here. I can now have a look. So I can go select star from raw stores. And I can see that that's got that same format that we were looking at in the CSVs here. So this is quite useful for bringing in reference data, but how did we actually get from a CSV file into the SQL that was used to bring this into the warehouse? So we can actually look at the SQL as it's defined by DBT. So I can look at in this target folder, I can see for my seeds, my raw stores model, this is the SQL that's been constructed on my behalf. So I can see that it's already handled the create table statements. From my profiles config, it's been able to determine that it should live in the DBT demos catalog and the Jaffle Shop demo schema. And also just, if I haven't told it otherwise, I can infer the name as the name of the CSV file. It's been able to parse through all the values there to determine which fields should be strings, which should be timestamps, which should be decimals. And then it's defined these insert overwrite statements here for me, and these placeholders we would use to insert the actual values from the CSV. So if I was to define this myself, this might take a fair bit of time, but if I just have my CSV file here, it's a lot easier to define that and deploy it. So that's a real useful feature of dealing with seeds here. So with those seeds, we've loaded that into our data warehouse. Now let's start to think about actually transforming that and going through our next few layers. So I've got my models folder here, and within that I've got subfolders for marts and staging, and these loosely map to my gold and silver layers. So within my staging, my silver layer, I've got a number of different SQL files that define the models in that silver layer. But in order to connect to those, I've also got this sources configuration file here. So remember that typically when we're working on a data project, we wouldn't be populating things with our seeds in DBT, but we'd have that data already loaded, say from an ingestion tool into Databricks. So from there, we need to actually establish a connection to that data. So that's what this sources YAML does for us. So here we're defining that we're pulling data from our Jaffle Shop demo schema. We're pulling in tables for tables known as raw customers, raw orders. And one of the extra things we've added here are descriptions. So you can see we've got raw customers being defined as one record per person who's purchased one or more items. So just bear in mind that we may come across those descriptions as we go further through the demo. And then some of the other metadata we've defined, we've said for our raw orders table, we've got a column called ordered at that would act as the field that defines when each record was loaded at. So that config is particularly useful if you want to do freshness checks here. So we can very easily define more data tests where we're checking how fresh the data is coming in. So because Jaffle Shop operates 365 days a year, we would expect to be getting fresh data for our raw orders coming in every single day. And if we have data that's more than 24 hours old, that's going to tell us that there's a problem and we want to jump on that. So by defining this freshness check and by defining what column should be used to verify the freshness of the data, we can set up alerting to warn us if that expectation is ever violated. So we can jump on that and potentially solve that problem before our business stakeholders are even aware of it. So that can also help to build trust if we can do that. Okay, so we've defined our sources for our bronze layer. Let's actually start to transform it. So this is where our staging models come in. So let's start by looking at, say, stage customers here. So here's our SQL for stage customers. You can see it's pretty simple. We've got a common table expression here. We've got a second common table expression where we're just applying some renaming of fields, and we're just defining a select star to say this is the definition of our staging model. So again, just some light transformations, but you might have noticed that in this first CTE, we've got this statement with these curly braces around it. So this is an example of Ginger, that templating language that we can use. So what this particular Ginger statement is saying is instead of having a hard-coded value, we want to parameterize the source for our raw customers here. So what that means is when this model actually gets executed, which I can do just by going dbt run, and I'm going to select this model. And in fact, I might even just run the entire subfolder. So I can just go models staging. And in the background, that's going to populate all these silver layer models into my data warehouse. And as it goes through, it's going to compile the SQL it needs. But as it does that, what it's going to do is it's going to look up my configs, look up my sources YAML, and determine what it should use based on the environment that I'm working with, what source it should use. So as I'm going through a development environment, through to test, through to production, I may want to actually change the source that I'm connecting to. Maybe I've got a dev that doesn't have as much data in there so that I can get better performance while I'm developing. So this allows us to parameterize things. So it's a lot easier, more modular to move between those different environments. So you can see it defining those views acted pretty quick. It took about 20 seconds, and look again at how this gets compiled. So I can look at my models staging in my targets folder, and I'll just look at stage customers. So here you can see it's wrapped a create or replace view statement around this. And it's also now hard-coded in the values for the table that I actually want to select from. So that makes things a lot easier and a lot more modular. So we've looked at one of these. Let's look at another one. So let's say our stage orders model. So again, we've got our same CTE where we're connecting to our source table in the bronze layer. And now we're defining another rename statement. So we're doing some simple renamings of our IDs to make things clearer. But you can also see that we've got some different fields where it looks like some values are in cents, some are in dollars perhaps. So let's actually have a look. So if we're looking at our raw orders table, is the thing I think the warehouse might need to spin up again, but there we go. Okay, so we've got our ID columns here. We've got our order that date, which represents the date time that the order was placed. And you can see we've got subtotal, tax paid order totals. I dare say that we're probably not spending $700 on a toasted sandwich, even though inflation has gotten away from us a little bit, but it's probably a bit high. So that value is going to represent the values more in cents rather than dollars. So I'm going to want to make that clearer to my end users. So I'm going to distinguish that where I've got my raw columns defined with a cents suffix, but then my actual values where I convert those cents to dollars, I've got those defined here. And I've got another Ginger statement that I'm using to define that. So I've got a cents to dollars macro that I've used. So you might be thinking, okay, well, converting cents to dollars, that's pretty trivial. Why would I not just divide the value by 100? And it's a good point, but there's a bit more going on under the hood. So let's actually have a look at the definition of that macro. So we'll go to cents to dollars here, and we can see there's a few lines going on here. The most important thing to look at for a start is this line here, where we're defining, whenever in our SQL statement, we're defining that cents to dollar macro, this is the code that gets replaced within there. So we're taking the column name that we use as an input parameter, we're dividing that by 100, but then we're also doing some typecasting here. So it can get a bit tricky to make sure that we're doing consistent typecasting across different models. So this ensures that we can have that consistency by storing that definition in the one place. So that's one of the useful elements where we can really define our logic in one place and follow that don't repeat yourself principle that you would often use within software engineering. So the other thing you'll notice as well is this line refers to the default logic for cents to dollars. But there's also a few lines here where we've got, what does that logic look like if you're connecting to Postgres, or you're connecting to Google BigQuery or Microsoft Fabric? So you often find that between different data platforms, there are slightly different SQL semantics that we need to cater to. So this macro is defined in a way that no matter which data platform we're connecting to, it's going to seamlessly supply the correct SQL semantics for us. And that's really useful for a few reasons. So one of which is, say, if I'm trying to make sure that I'm optimizing my costs for my data platform, I might say to my developers, because we've got a lot of heavy compute that might be happening while we're developing new models, instead of doing that work against Databricks, when you're in development, you can actually just use a local DuckDB database on your own machine. And this definition, the definitions of all these macros allow us to seamlessly move between different database or data platforms without having to rejig our code because it's all contained and parameterized here. And the other thing as well is if we want to be a bit more portable, maybe we're considering going through a migration onto a different data platform. This makes it a lot easier to lift and shift between those because as long as we have things defined in this way where we're shifting the SQL semantics in our macros, it happens a lot more seamlessly. So that's a bit about our macros here. So if we actually look at, now that we've ran the execution of those view definitions, we can look at how this gets compiled. So we can see for our stage orders model, this is the SQL that gets generated. So it's substituted in the full table reference. It's substituted in our full macro logic for our subtotals, for our typecasting. So that's pretty useful. That's handled out of the box. And that, again, allows us to scale a lot more quickly because we don't have to manually define all of these. We just use those macros. Okay, so that's been our silver layer. Now let's start to think about finally serving this up for our end users. And as soon as I start to serve these things up, I'm usually doing a lot of conforming of different entities from upstream, and the lineage can get a bit tricky to wrap our heads around. So what I can do is I can actually have a look at what that lineage looks like, and I can use the out-of-the-box dbt docs tool. So from here, what I've just done is I've sent a command that's going to generate all my documentation for me in the form of data dictionary that really just happens by parsing through the entire project, working out all the dependencies, all the models involved, all the descriptions and the configs, and it's going to build that from there, and it's now defined that catalog for me. So now if I want to view that, I can just go dbt docs serve, and that'll create a local website that I can use to actually view those definitions. Here we go. All right, so this is a full documentation site that's been made for me out of the box. So I can use this to explore and understand what are the sources that I've got within my project. So I can see here are my raw customers tables, my raw products. Say looking at raw customers in detail, I can see here's that description that I defined in my YAML configurations. Here are all the columns and the column types I'm using. I can see the SQL definition of that if I want. And I could also navigate through this hyperlink to see what does the related stage customers look like. So here again, I've got descriptions, I've got here column level descriptions, and I've even got data tests defined against this particular column. So so if I want to fully understand the lineage here, it gets a bit cumbersome to navigate between these hyperlinks to understand it. So it's actually more helpful to look at a lineage graph here. So if we're just talking about our customers entity, it's pretty trivial, just going from bronze to silver to gold. But let's actually look at how the whole project is put together. So here you can see up here I've got my seed, which bronze seed. I can see that they're connected to the rest of these. They flow into our silver layer, so stage order items, stage orders, and they all combine up to our gold layer here. So we've got entities for products, for order items, orders, customers. So the other final type of entity here that we've got is this little test here. So we can see that for our staged locations model, yes, it generates the gold locations table, but it also creates this test. So this test is named test, does the location open at date truncate to a date? So let's actually look at what that's talking about. So if we go to our stage locations, and I'm going to shrink this back again. So we'll go back to models, staging, and then that was locations, wasn't it? So instead of looking at the SQL definition, we can look at our YAML configs for this model. So here, this is where we define the description that appears in our documentation site. This is where we define, again, even the column level descriptions. But then we've got two different types of tests. So we've got our data tests and our unit tests. And there's a slightly different context that each of those is used on. So when we talk about a data test, what we're saying is, okay, through that deployment process, we've defined our table or our view, we've populated it with data. Now let's actually run some tests against the data in there. So we can run queries to determine, are the values in that location ID column always unique? Are they always not null? And typically, if I want to write my own hand rolls equal to that, and what I can do is I'm just going to cancel out of that documentation site. Oh, that's fine. I'll give it a moment. But in any case, I can
Sam,
actually execute these tests and see what that gets
Sam,
compiled to. So again, I'm going to just run the tests against my stage locations model.
sorry, Sam,
Mm.
your audio is breaking up a little bit. Can I suggest maybe you just turn the camera off to free up some bandwidth?
Yeah, can you hear me?
Struggling to hear you now, Sam. You're just a bit choppy. We'll give Sam just a minute to reconnect, guys.
Right. Yeah, is that any better?
That's much better, Sam.
Yep, there we go. Sometimes the old turn it off and on again is all it takes. Okay, so we've just ran these tests that we've defined. So we've got our data test. It's ran a test against the view to determine if the values in the location ID column are unique and not null. And again, we can look at the SQL that's defined as. So I can go to my models. I can see that for the staging model under my stage locations YAML, this is the actual SQL that gets defined for me. So it's going through each of the unique values in the location ID. It's counting how many times it sees that ID, and it's returning any instance where I've got more than one record against that location ID. So doing these kinds of checks, this will return any exceptions that I might have to that expectation. And handwriting this for every single column's going to get a bit cumbersome and hard to maintain. But what's useful is I've just defined the config here, just 6 letters, and it's done for me. So that's covered all out of the box. So that's our data test. The other instance is our unit tests. So let's say that I've got some particularly complicated logic and it's hard to work out what is the SQL to define all the different scenarios that that might cater to. So what I can do is I can just treat those SQL transformations as a black box. From that, I can just define what are some input data that I would expect to supply to that black box. And from that, what would the black box transforms return as an output if it's doing what I expect. So in this example, this is saying that we're expecting the open date time to be truncated to a date. So we would say that if we have this opening date time, we'd expect to get this date out the other end. And that unit test has actually been run for us where it's executed that to determine that, yep, that works just as expected. So this is how we can also do tests. The useful thing is this can actually be defined before we actually populate any data within the table. So that means that we can save on compute costs if we're defining things in that way. Okay, so that just about brings us to the end of the demo. So I'm just going to swap back to PowerPoint and we can wrap up from there. All right. So to summarize, what have we gone through in this session? So we've covered off on what is DBT as a tool that helps us as a member of a data team. We've gone through what are the key features and how that enables our data team to deliver good outcomes. We've gone through what's the journey that you would take to reach maturity with a tool like DBT. And then we've also looked at the different offerings of DBT that might help us supercharge that. From there, we've gone through our demo where we've first of all connected to our data platform and then connected up to source data. We've ran and executed some models within our platform. We could see how quickly that was and how easy it was. We've been able to scale our usage with macros rather than just having to hand roll all of our SQL. And then we've also explored and understood the models, and ensure that we have high data quality with those tests that we have defined there.
Sam, I think we're good.
Yeah, I think so.
What I'll do is this will get posted up in a couple of days. Like I said, on our LinkedIn channel and on our YouTube channel. So what I'll do is I'll share the links with all of the attendees so they can pass that on to the rest of the team. But thank you very much once again, Sam, and thanks everyone for coming.
Brilliant. Thanks, everyone.